So this is a nice unit because it reviews our graphing parabolas unit that we did earlier that you're going to need to know for your exam. What? So if we first graph y equals negative 2, x plus 2 squared plus 2. Do you remember that you could find the vertex of this one quite easily? It's going to be at negative 2, comma 2. So I go to my graph. And I go negative 2, comma 2. That will be my vertex. Also, do you know that this parabola is opening down? Because the a value is negative. And the a value being negative 2 would mean you would go over 1, down 2, then over 1, down 6. So a review of graphing parabolas. It is going to be very important in graphing parabolas that we find our x-intercepts in this unit. So I have an x-intercept at negative 1, 0, and negative 3, 0. And my y-intercept here is at 0, negative 6. So a review of graphing parabolas. Knowing how to graph your parabolas is going to be very important to this unit, because now that we've graphed that, we can easily graph, and I'll change colors, we can easily graph the absolute value. Because what does the absolute value do? It just takes your y values that are negative and makes them positive. So first of all, can you see that this section right in here of the parabola would stay the same? Because there my y values are already positive. And so if I did the absolute value of a positive number, it would stay positive. But this point 0, negative 6 is now going to become 0, positive 6. So we take this section down below and it gets flipped up. Same thing on this side. It would get flipped up as well. So our final graph looks like a W. In our green graph, can we just say what the intercepts are? Yes, we know that our y-intercept is 0, 6. Our x-intercept stayed the same. They were at negative 1, 0, and negative 3, 0. Domain was everything, and range, our y values are now bigger than or equal to 0 on our green graph. Yes? Is this always going to be our range value? For absolute values, if the graph goes down forever and it flips up, yes. You will sometimes, like when you get to grade 12, they will ask a similar question, but they'll give you the graph. They'll say, maybe my original graph went like this. Up to, it started at 2, went over, started here, went over to here, then went down 1, 2, 3, and then went up. What does the absolute value graph look like? In grade 12, you'd be like, oh, this stays the same. What's going to happen with the bottom part? It's going to get flipped up. So now your range is like from 0 to 3 or something like that. So I'm hesitant to say, is it always y greater than 0? For lines and parabolas, the answer will be yes. But in grade 12, you might get new graphs that you have to do the absolute value that don't have always the same range.
So the domain isn't XER for this one?
The domain is everything for lines and parabolas, because the domain of the blue one was everything. This one would be from here to here, because it stopped. So I'm hesitant to say it's always something, because I can think of graphs where it's not. But for what we're going to be doing this year, lines and parabolas, yes. Your domain will always be everything, because your line domain is everything. Your range will always be bigger than or equal to 0, because you're flipping something up. So let's look at part B. Part B, we would first graph I'll do it in blue again. Y equals negative 3x squared minus 1. So again, can you see that it's in vertex form? And the vertex would be at 0, minus 1. So as far as graphing that first, I would have 0 and minus 1 as my vertex. Which way does this parabola open? Down. So it's going to go over 1, down 3, over 1, down 3. I could label those points. I'd have 1, comma, negative 4, negative 1, negative 4. You can double check that. Does it make sense that if I plug in 1, 1 squared is 1 times negative 3, negative 3 minus 1, I will get negative 4. You can always test your points by plugging them in. And my parabola, my original parabola, looks like this. Do you see that the y values are always negative in the original parabola? So when I do the absolute value, when I go to graph in green, the absolute value of negative 3x squared minus 1, it's going to take this whole part. Oops, that's not green. This one is going to become 0, 1. 1, negative 4 is going to become 1, positive 4. And it's going to flip the whole thing up as a result. Oh, which gets to our question. Is the range always the same? Not in this example, right? The domain, first of all, there is no x-intercepts. The y-intercept is at 0, 1. Our domain is still everything, but now our range, now it has the smallest y value of 1, so our range is bigger than or equal to 1. Questions for practice on this one are 4, and now you can do 5, the rest of 5, 6, oops. Oh, we did 4 already, sorry I'm giving you the wrong number. We can do the rest of 5, the rest of 7, the rest of 10, and 15.